Okay, so on the question number 1 on this online topic 4 test, it says find the sum of the difference of these. Remember, when you're adding matrices or subtracting matrices, you're just number one, have got to be the same size matrices. But if I'm adding, I just add each corresponding element. If I'm subtracting, your rule is to add the opposite here. So if I'm doing this mentally, this is 9 minus a 7, so it's the same thing as 9 plus a negative 7, which would be a positive 2. So far A looks good. And then the next one's 2 minus a negative 5, so I'd add the opposite, so that'd be 2 plus a positive 5, which is 7. So it's not A. 2 negative 3, nope. 2 positive 7, yes, it could be C. Or D. So I'll check the next one. What's 8 minus 6? That's a positive 2. So positive 2, this is an 8. Obviously, it's not D. It must be C. Let's check the last one. Negative 1 minus a 3. So negative 1 minus a 3, you would add the opposite. It would be a negative 1 plus a negative 3, which is a negative 4. So yes, it should be C. Okay? So let's go to the next question, 2. Find the sum of or difference. Once again, that's a 3 by 3 plus a 3 by 3. Can you add them? Absolutely, you can add them. Okay? So if I can add them, I just add the corresponding elements. So what's 1 plus 22? 23. And then 11 plus 7 is 20. So I'm at a 23 and a 20. So far they all look good. 16 plus a negative 18 would be a negative, or excuse me, a positive, or a negative 2. Should be a negative 2. Negative 2. So it's either A or C. Check the next one. 24 plus 5 is 29. Okay, so A looks good. C still looks good. Now right here that we finally have a difference in A and C. This is a 12, this is a negative 18. So if I take that element, which is a negative 3, plus the 15, what's a negative 3 plus 15? 12. Let's check the other ones. 19 plus 11 is 30. 9 plus 12 is 21. 10 plus 14 is 24. 20 plus negative 17 is 3. So it should be A. We good with that one? Questions? Okay, let's go to the next one. A student says that A, B, C, D plus A, B, C, D plus A, B, C, D plus A, B, C, D is equal to the matrix 4 times A, B, C, D. Is that right or is that wrong? Well, if I were to multiply this out, this would be this row times this column, so it would be 4A plus 4C. Right? Plus the next row times the next column, right, would be the 4A, or excuse me, 4B plus 4D. Right? Plus the next row times the next column, that next entry would be a 4A plus the 4C, and then plus the next row times the next column, the last element would be a 4B plus 4D. Is that the same thing as this? No, this is nothing more than repeated addition. Repeated addition is scalar multiplication. This A, B, C, D plus A, B, C, D, see how these 4 identical matrices added together would just be nothing more than 4 times A, B, C, D. So it should look like that. Which would end up being 4A plus 4B plus 4C plus 4D. So, no. Alright, so what's the student's error? You can't add matrices with variables, only matrices with variables in it. Repeated matrix addition is equivalent to scalar multiplication. Yes, not matrix multiplication. So, that should be B. Alright, let's see the next problem. Find the product if it exists. If it does not exist, choose undefined. Okay, so first of all, to see if these can be multiplied together, I take and look at the dimensions of the first matrix. How many rows are there in the first matrix? 3 rows by how many columns? 2 columns. Can I multiply that by what size matrix is the next one? 2 by 2. Can I multiply it together, yes or no? Yes, I can, because the inside elements are the same. And then my resulting matrix is going to be what? Some 3 by 2 matrix. So it has 3 rows by how many columns? 2 columns. What would those entries be if we did that with pencil and paper? I just take this row, 2, 1, times this column, 2, 1. So it would be 2 times 2, which is 4, plus 1 times 1 is 1, which would be a what? 5. Take that same row times the next column, so it'd be 2 times 4 is 8, plus 1 times 6 is 6. 8 plus 6 is 14. The next row times the first column again. 3 times 2 is 6, plus 0 times 1 is 0. 6 plus 0 is 6. This row, 3, 0, times the next column, 4, 6. So it's 3 times 4 is 12, plus 0 times 6 is 0. So 12 plus 0 is 12. We see an answer yet? Let's take this bottom row times this next column. 7 times 4 is, or 7 times 2 is 14, plus 4 times 1 is 4. 14 plus 4 is 18. Very good. 7 times 4 is, so I'm just taking this last row times this last column. So it'd be 7 times 4 is 28 plus 24. What's 28 plus 24? 1252. So my last one would be a 52. Y'all find that answer? Which one is that? B? Got it? And then we go to the next one, unless there's a question there. You could plug that in your calculator, but find the product, if it exists, of this scalar matrix times this 2 by 2 matrix. Well, you just multiply each element by that scalar. So it'd be negative 3 times 3, which is a negative 9. Negative 3 times 10 is a negative 30. Oops, so it should be a negative 9, negative 30. And then a negative 3 times a positive 21 is a negative 63. And then a negative times a negative would be a positive 12. So it looks like it should be C. Is that right? Negative 9. Let me double check. Yep. So it's C. All right. Let's go to the next one. Find the product if it exists. If it does not exist, choose undefined. So first of all, what's the size of this first matrix? So 3 by 3. And we're multiplying that by a 2 by 3. Is that possible? Not possible. That's undefined. That would be D. Got it? Okay. Find the product if it exists of this one. Well, if it's a 2 by 2 times a 2 by 2, most definitely it's going to exist. So let's just do this with pencil and paper again. It's 3, 2, 0, 0 times a 0, 4, 1, 0. So I'm taking this row times this column. So it'd be 3 times 0, which is 0, plus 2 times 4 is 8. That's my first element. And I have another one. To get my second element of that row, I take this row times this column. So it'd be 3 times 1, which is 3, plus 2 times 0 is 0. Now let's find that next entry. That next element comes from this row times this column, each element. So it's 0 times 0 is 0, plus 4 times 0 is 0, so it'd be 0 plus 0. Once again, I'm going to take this row times this next column right here. So it's that element, 0 times 1 is 0, plus the next element times the next element is another 0. So 0 plus 8 is 8. 3 plus 0 is 3. 0 plus 0 is 0. 0 plus 0 is 0. So it should be 8, 3, 0, 0. Which is answer choice A as in apple. You can plug that in your calculator and do the same thing. Alright, it says, explain how to find the determinant of a 2 by 2 matrix. Well, if I had this 2 by 2 matrix, and if I wanted to find the determinant of it, I'd just take the product of the main diagonal, which is 8 times 0, which would be 0, minus the product of the subdiagonal, which is 0 times 3. So which one basically says you find the difference of the main diagonal and the subdiagonal? Is it A, use the scalar multiplication with the transpose of the matrix of the inverse determinant of the matrix? Add all the elements of the matrix together, subtract them from 0, multiply the elements of the matrix together and find the multiplicative inverse of the product, or find the difference of the products of the elements in each diagonal? D. Right? We good with that? Alright, find the inverse of this matrix if it exists. Well, how do I know if the inverse exists? Y'all remember how to do that? Find the determinant. The determinant of that would be the product of 6 times 2. The main diagonal is 6 times 2. Minus the subdiagonal is 2 times 3. So 6 times 2 is 12, minus 2 times 3 is 6, which is 6. That's the determinant. Y'all with me? So is there an inverse? Yeah. So obviously it's not D. Which one of these is the inverse? Well, now I calculate the inverse either in my calculator or with pencil and paper. Pencil and paper, I take 1 over the determinant times, what do I do with this matrix? Do y'all remember? On the main diagonal, what do I do? Switch them. So that 6 and 2 changes places. And then the subdiagonal becomes the negatives. And just multiply 1 6 times 2. What's 1 6 times 2? 2 6. Very good. What's 1 6 times a negative 2? Negative 2 6. What's 1 6 times a negative 3? Negative 3 6. And then 1 6 times 6 would be a 6 6. And then reduce those. 2 6 is what? 1/3. Negative 2 6 is negative 1/3. Negative 1/2 and 1. If I did my math right and followed my rules right, that should be the correct inverse, but I want to check it, right? So it looks like it's C, but let's check it. How can I check it really easily? Cut on your calculator, create a 2 by 2 matrix. Look, a fast way of creating a matrix is over here to the left of the little bookmark. Right? And there's a 2 by 2 right there. Highlight that and hit enter. And then enter each element. So it's 6 tab, 2 tab, 3 tab, 2 tab. And then just raise it to the negative 1 power and you found the inverse of it. Remember in your calculator, just raise it to the negative 1. Hit enter. Do I get the same thing as what we calculated? Kind of hard to see. 1/3? 1/3? Negative 1/3? That cursor out of the way. Negative 1/3 there. Negative 1/2 1. Yep. So we can do it pencil and paper, or we can do it with a calculator. Find the inverse of this matrix if it exists. Once again, to do it in pencil and paper, let's find the determinant. So to find the determinant, I take 7 times negative 16 minus the product of the subdiagonal is 8 times negative 14. So 7 times negative 16, I don't know what that is off the top of my head. It's negative 112, is that right? Minus 8 times a negative 14 is another negative 112. So you add the opposite, you get 0. What does that mean? Yeah, there's not an inverse to that. So if the determinant is ever 0, there's no inverse to that. Now, how else could I find the determinant by using my calculator? I can just type in DET for determinant, open your parentheses, and create that 2 by 2 matrix that you want to find the determinant of. So that's 7, 8, negative 14, negative 16, and just hit enter. And that's 0. If the determinant is 0, what does that mean? There's no inverse. Why? Because to calculate the inverse, I would have to take 1 over 0, 1 over whatever the determinant is, and multiply it by what? Negative 16 and 7. The main diagonal is changing places, and then the subdiagonal would change signs. So that would be a negative 8. What would this last entry right here be if I change the signs of the subdiagonal? That 8 became a negative 8. So what does that negative 14 become? Positive 14. And if you take 1 over 0 times 1/16, that's undefined. Because 1 divided by 0 you can't do in your calculator, right? If I try to do that in my calculator, 1 divided by 0 is what? Undefined. Now, I could have also found that that would have been undefined as well by just going to enter your 2 by 2 matrix and find the inverse of it. How do you find the inverse of this 2 by 2 matrix? You could have just gone 7, 8, negative 14, and then entered a negative 16, and then raise it all to the what power to find the inverse? -1. And then it says error, singular matrix. What does that mean? It has no inverse. There is no inverse to that. Okay? Let's go to the next problem. Find the inverse of this matrix if it exists. Once again, to find the inverse of the matrix, I could find the determinant and do it with pencil and paper, but I told you don't worry about a 3x3. You can always do it in a calculator. It saves you time and it's a lot easier. So just enter your 3x3. Tab, tab, okay. And then enter each element. 1. Oops. Tab, I hit enter. 1 tab, 2 tab, 3 tab, 2 tab, 2 tab, 1 tab, 1 tab, 1 tab, 1 tab. And then raise it to the what power to find the inverse? To the -1 power. Right, to raise it to that power, it says right there. And then hit enter. There's my answer. Which answer choice is that? Is it B? B looks right to me. Looks like the same one, so let's go to the next problem. Which of the following is not a matrix operation or property that you could use to solve the following matrix equation? Could you use scalar multiplication to help you solve this? Absolutely. You can take 2 times 4 and get 8, and that's 2, and that's 4, and that's -6, plus this 2 times x. So scalar multiplication is okay. All right? What about subtraction property of equality? Well, to get rid of this side right here after I multiply, wouldn't I subtract the left matrix and then subtract it from the right side? Because whatever you do to one side, you do to the other. So I could subtract whatever this product is to this side, so that's okay to do. What about matrix subtraction? Okay, well, would I subtract matrices in this? Absolutely, because if I subtract this side, I'd end up subtracting over here to the right side a -8 and a 2, and then that 4, and then that -6 from this 2x2 matrix. So that's fine. What about matrix multiplication? Well, why would I use matrix multiplication to solve this problem? Well, I could, because my last step would be to divide by 2, which is the same thing as matrix multiplication. So which of the following is not a matrix operation or property that you could use to solve the following matrix equation? Looks like all of them I could use. I don't know which one that would be, because it seems like every single one of these would be one. No, I wouldn't use matrix multiplication. I'd use scalar multiplication. You're right, because that right there, to get rid of that 2, I would multiply by 1/2. So yeah, D. That would be the best answer choice, because I'd use scalar multiplication twice. My fault. So it's D. All right, let's go to 13. Find the determinant of this matrix. Once again, to find the determinant, I just take the product of the subdiagonal minus, or excuse me, the product of the main diagonal minus the subdiagonal. So we could do that mentally, right? Or actually, we could do it with pencil and paper. That would be 6 times 8, which is -48, minus the subdiagonal is -35. So you just subtract those by adding the opposite. So what's -48 plus a positive 35? Signs are different, so you subtract the 2 and take the sign of the larger one. Should be a -13. Do we all get -13? Now once again, to check it, we could just do it in a calculator. We could find the determinant, which is nothing more than DET, but you got to make sure you open up parentheses here. So once you type in DET, open up parentheses and then enter that 2x2 matrix by going right here to the left of the book, highlighting the 2x2 matrix, and then enter each element. -6, -7, tab 5, tab 8, and then enter. So we did it right. So we can check our math just in case by using the feature, the determinant feature of the calculator. Once again, to find this determinant, it would be 9 minus a positive 10, which would be a -1. The main diagonal is 9 minus a positive 10. 9 minus 10 is a -1. Everybody good with that one? All right, let's go to 15. Find the determinant of this matrix. Once again, we could do this with pencil and paper. Some of you guys kind of had some trouble with that on the test, so let me show you how to do it pencil and paper real quick. You just copy down your matrix. 1, 2, 3, 6, 0, 5, 0, 4, 0. Y'all had trouble with this on the homework check, so if y'all have to redo the homework check, here's all you got to do to find the determinant without a calculator is recopy column 1 and then recopy column 2, and then now do your main diagonal, which is 1 times 5 times, oop, I messed that up. I messed that up completely. Let me start over. That's ugly. I didn't have it lined up at all. 1, 2, 3, 6, 0, 5, 0, 4, 0. There's my main diagonal there. And then recopy this 1, 6, 0. So I can do my next diagonal, which is 2 times 5 times 0. And I recopy this 2, 0, 4. So I can take my 3 times my 6 times my 4. So my main diagonal would be 1 times 0 times 0, which is 0, plus 2 times 5 times 0 is 0, plus 6 times 3 is 18 times 4. 18 times 4 is what? 72. Minus my subdiagonal would be the product, the sum of the products of 0 times 3, which is 0, plus the 4 times the 5 times the 1, which would be 20, plus the 0 times the 6 times the 2, which is 0. So that would be nothing more than 72 minus 20, which is 52. So that should be C with pencil and paper. If you want to check it, an easy way to find the determinant, obviously, is just to type in DET, open your parentheses, add that 3 by 3 matrix, and then just enter each element. 0, 5, 0, 4, 0, and then enter. See how we still get the same 52? So pencil and paper versus calculator. The calculator is obviously faster. Just make sure that you understand how to do it pencil and paper. All right, how do I tell if these are inverses of each other? Can y'all tell me? I'm not going to try to trick you on the test. If you take them and multiply them together and you get the identity matrix back, then they're inverses. So if I have some 2 by 2 times some other 2 by 2, and if I multiply it together and if I get the identity matrix back, this diagonal of 1s and everything else zeros, then they're inverses. So I just have to multiply them. So to multiply matrices on your calculator, once again, you could just go to menu 711, or I can go to the left of the book and create a 2 by 2 matrix here. Right? And so what's the 2 by 2 matrix I'm going to multiply? It's 2, negative 1, negative 3, 1, times, so hit times. Create another 2 by 2 matrix, and then that would be your negative 1, your negative 1, your negative 3, and your negative 2. And then just hit enter. Are they inverses? Sure. If you wanted to check it, what we could do to check it is we'll just switch the order of those two. So to verify it beyond a shadow of a doubt, because if you don't trust me, I'm not trying to trick you, you do it in the opposite order. If you take B times A and you get that back. So let's just do that just to verify, because if A times B and B times A is that identity matrix, then they're definitely inverses. So my second matrix this time is negative 1, negative 1, negative 3, negative 2, times your other 2 by 2 matrix is 2, negative 1, negative 3, 1. Yep. See how I get the identity matrix back? In either way, then they're inverses. So, are they inverses of each other? Yes. Because when you add them together, you get the 0 matrix. Is that why? No. Because when you multiply them together, you get the identity matrix back as well. So that's D. Let's look at 17. Solve the matrix equation. So to solve a matrix equation of 3, 4, negative 1 times some other matrix is equal to 3, 2. in order to solve that matrix equation, the first thing I've got to do is to get that to become the identity matrix. So if I can get that to become the identity matrix, any number times that identity matrix would give you that x back. So it's just like saying 1. So if I multiply this by the inverse, it'll end up giving me the identity matrix if an inverse exists. So hopefully an inverse will exist, because if I multiply this to find the determinant, that would be a -3 minus a -4. Obviously that's a number, that's not 0. So yes, I can find the inverse of this matrix. So I want to find the inverse of this 3, 4, -1, -1 matrix, and multiply by this, and it gives me the identity matrix of a 2 by 2 back. And the identity matrix of a 2 by 2 times any other matrix will give me that matrix back. But just remember, what you do to one side of the equation, you got to do to the other side. And this is where it's very important. If you're solving it this way, you have to do this in a specific order. So if I took 3, 2 times the inverse of this 3, 4 negative of this 2 by 2 matrix, am I going to get the right answer if I do it in this order from left to right? No. Okay? You've got to do the inverse matrix first and then multiply that by the 2 by 1 matrix. So I've got to find the inverse of this 3, 4, -1, -1, and then multiply by the 3 by 2, and I'd get it right. So to save some time, we could do that in your calculator just by going to your calculator section and then enter that inverse matrix in by going to your little cheat sheet, enter your 2 by 2, and that would be that 3, 4, -1, -1, and then raise it to the -1 power to find the inverse of that, and then multiply that by this 2 by 1 matrix. So to create a 3 by 1 matrix, there's a little shortcut for that too to the left of your little book. Okay, a 2 by 1 matrix is right here, and then you just enter the element 3 tab 2 tab. Otherwise, you hit menu 711 and create a 3 by 2. So what do I get? I get x to be equal to -17.5. If you wanted to check it, you can just take this matrix right here times this matrix here and see if you get 3, 2 back. If you do, you did it right, which it should be right. So that should be A. All right, I'll do one more with you, and then you can do the rest on your own. Solve this matrix equation. So first of all, this one's not as hard. This is 6, 2, -1, 4 minus some matrix is equal to 8, 1, 3. So to solve that, all I have to do is get rid of this 6, 2, -1, 4, and that's a positive matrix. So just think of an equation where that's like a positive 6 minus x is equal to 15. How would you get rid of a positive 6? You would subtract 6. So in this one, we're doing the same thing. So you just subtract this matrix. 6, 2, -1, 4. What you do to one side of the equation, you got to do the other. So it's 6, 2, -1, 4. So that would be 0. 0 minus x is x. And this would be 8 minus 6. Right? 8 minus 6. So we have to subtract the corresponding elements. 1 minus 2, 1 minus a -1, and then 3 minus a -4. But it's easier if I use my subtraction rule, which is to add the opposite. The opposite, the opposite, the opposite, and the opposite. And then add the corresponding elements. So this is 8 plus a -6, which is a positive 2. 1 plus a -2 is a -1. The 1 plus a 1 is 2. 3 plus -4 is a -1. Now, I don't see that as an answer because this is -1 times that. So to get rid of that -1, if I multiply by a -1, it becomes a positive 1. Positive 1 times x is x. But whatever you do to one side of the equation, you got to do the same thing to the other side. So I got to multiply every term over here by a -1, and I have my answer. -1 times 2 is a -2. -1 times a -1 is a positive 1. -2, positive 1. So there we go. Should be a -2, -2, 1, 1. Or -2, 1, -2, 1. Y'all see that anywhere? -2, 1, -2, 1 is A. Okay? So y'all do the rest on your own. If you have any issues with it, let me know. But finish this up for your homework, and this will be due tomorrow, and you have a test tomorrow over all this stuff. Okay? I figure that's plenty of time. We got it?